Transferring thermal energy. The term thermodynamics comes from Greek words that mean heat force. When discussing thermal energy, we still apply the law of conservation of energy, meaning that thermal energy doesn't just magically disappear or appear, but it is transferred to or from other objects, or it is created by work. Now, there are three ways that energy is transferred from place to place. This is by conduction, convection, and radiation. Because particles in matter are in constant motion, they transfer thermal energy by collisions between these particles, and this is called conduction. You may have actually experienced conduction if you've ever touched a hot pan on the stove or maybe held a heat pack in your hand. Imagine holding a metal spoon in your hand. You are holding it by the handle end and you put the curved spoon over a flame. Now the spoon particles in the flame will start increasing the kinetic energy. And that kinetic energy is transferred when those particles start colliding with neighboring particles. The thermal energy is transferred by collisions between particles all the way up the spoon as these collisions continue, eventually getting to the end of the spoon that you are holding, and you will feel the heat from the flame. And this is because heat is transferred by conduction or collision between the particles without transferring matter. Convection is the transfer of thermal energy in a fluid by the movement of warmer and cooler fluids from place to place. Remember that fluids can either be liquids or gases. When conduction occurs, the particles with more energy collide with particles that have less energy and transfer thermal energy. However, when convection occurs, the more energetic particles move from one place to another, and as they move faster, they tend to be further apart. The third way that energy is transferred is by radiation. And radiation is the transfer of energy by electromagnetic waves and is often called radiant energy. These waves can travel through space even when no matter is present, and that is why you can feel the radiant energy of the sun. You also feel radiant energy when you stand near a fire and warm your hands. This warmth you feel has been transferred from the fire to your hands by radiation. It's important to note that when talking about conduction, that although heat can be transferred in all materials, the rate at which heat moves depends on the materials. So, heat moves faster by conduction in solids and liquids than in gases. This is because in gases, particles are further apart, so collisions with these particles occur less frequently than they do like in solids and liquids. The best conductors of heat are also metals, and this is because metals have electrons that are not bound to individual atoms and they can move easily throughout the metal. We've also discussed that convection occurs in fluids, which is liquids and gases. So we need to remember that when a liquid or gas is heated, the particles expand. You have seen this if you've ever seen a hot air balloon get blown up. The flame is turned on and the heated air expands into the balloon. And as it expands, its density decreases, allowing that balloon to rise. If you've ever seen a lava lamp in action, the heat from the light at the bottom of the lamp causes one fluid in the lava lamp to expand more than other, and it will rise, and when it rises to the top, it cools, becoming more dense, and it drops back down to the bottom. And then until the light heats it up again, it becomes less dense, and it will keep rising and dropping, creating what is known as a convection current. In nature, convection currents occur in the air and in the oceans, and this is what drives the Earth's weather and climates. Now, radiation is most important in gases, and because molecules are much further apart in gases than in solids or liquids, radiation usually passes more easily through gases than solids or liquids. We also want to talk about trying to control heat flow, and when we do that, certain materials are used. Material in which heat flows slowly is called an insulator, and a good example of insulator is wood, some plastics, fiberglass, and even air. When you go out in the winter and you put on a jacket, the purpose of your jacket is to insulate you or keep you from getting cold, and this works by reducing or slowing down the flow of heat from your body to the surrounding air. Inside your jacket, there are fibers that trap air and hold air next to you. And this air slows down the flow of your body heat going to the colder air outside the jacket. Gradually, the air trapped by your jacket is warmed by your body heat, and underneath the jacket, you are wrapped in a warm blanket of air. Now, materials such as metals that are good conductors of heat, of course, are poor insulators. These materials they have heat, and the heat flows more rapidly from one place to another using conductors. All right, let's go ahead and take a break here. It's time for you to show what you know.